In our today's class, we want to look at our third topic in our course outline. That is assignment problem. Now, assignment problem is a special type of linear programming. And because it is unique, therefore we can neither use what we call the simplex method or the graphical method to solve it. And I just want to take you through 6 steps of solving an assignment problem, or the so-called assignment algorithm. Okay, so we have 6 steps of solving an assignment problem. The method is called Hungarian method. This is the method that we use in solving an assignment problem. I said this is a special type of linear programming, and therefore we can neither use the methods that we had learned previously to solve it, and therefore it has a special method that we are using. So now in this method we have around 6 steps that we need to follow. So the step 1, you need to check whether the problem you have been given is a minimization problem. Minimization problem. This means that all assignment problems are supposed to be a minimization problem, or it's a minimization model. And therefore, that does not mean that we cannot find a case whereby we have been given a case of maximization. If it is maximization, under these steps indicate that you need to convert it to minimization in case it is maximization. In the same step, you need to check whether the problem is balanced. For instance, a manager may have 4 employees to assign to 3 different jobs. In this case, the 3 employees will be assigned to each job, and 1 employee will remain unassigned. In this case, it means that it is an unbalanced problem. So in this model, it is indicated that under this step 1, you need to ensure that you balance it. It means you create an imaginary job, or what you call the dummy job, and assign a unit values of 0 so that we can have 4 employees and 4 jobs. So before we start solving assignment problem, we must ensure, number 1, that it is a minimization problem. It means all assignment problems are minimization. And in case we have maximization, then we need to convert it. And the only way of converting it is that you need to look at the highest unit value in the matrix that you'll be given. And you use that highest unit value to subtract all the unit values that have been presented in that matrix. Now that matrix that you'll end up with is actually now a minimization problem. So step 2, this step 2, you need to do what you call check at row minimum. This is row minimum. Identify the row minimum value. If, for instance, a row we have 1, 2, 3, 4. This is a row consisting of 1, 2, 3, 4. The minimum value in this row is 1. This is the list. So you need to identify the list value. So this list value, you will use it to row reduce the entire row. This means therefore that the first one will be reduced to 0. This becomes 1. This becomes 2. This becomes 3. I've used this to subtract from all the elements in this matrix. So that is what we are supposed to do, doing what we call the row minimum reduction. Then step 3 is you do what we call column reduction. So under column reduction, if you have the column is 2, 3, 4, 3, 6, 7, then you check at the least value in the column, like 2, 3, 4. The least value here is 2. But we use 2 now to reduce that column. So this will transform now to 0. This becomes 1, and this becomes 2. So this is now the transform. That is what we are supposed to do. Now this step 1, step 2, and step 3 normally are called phase 1. This phase 1 of solving what you call an assignment problem. Now once we are through with the phase 1, we go to phase 2. Phase 2 also has what we call 3 steps, which means now we shall be looking at what we call step number 4. Step number 4, and this is now phase 2 is the phase of testing for what we call optimality. optimality. We want now to assign the values. If there are employees, we want now to assign them to the various jobs. And in assigning, the rule here is you start by what you call checking at the unique zeros. We will see when we give an example. You assign at unique zeros. So unique zero in the row first, then you check the unique zero in the column, and you assign. So that is now what you call assign at unique zero. That is now our step number 4 on. We are now going to test for what we call optimality. Now step 5 require you to ensure that your assignment, the units that you have assigned, if it is 4 by 4 matrix, you assign until all the employees are fully been assigned. If they have been fully assigned, then you only move to our final step where you now present the values. If you have not been able to get the full assignment, one person is still left, then you are expected to go to the final step, and this final step will require you to identify all the values of what you have been assigned. You will realize that there are some matrix unit elements that have been assigned at cross intersection. There are others that are not being crossed completely. There are ones that have been crossed only once. So what it happens is that the ones that have not been crossed completely, like this 1, 1, 1, 1, 2, we have not crossed them. You identify the least value. So this least value are the ones that have been crossed twice, which means point of intersection, like this point and at this point. You add that unit element to this value, which is here. If this one was 4 initially, and the least element is 1, so you add 1 together with this, will be 4. And the ones that have been crossed once, you leave them the way they are. But the ones that are left without being crossed, you subtract that same list value. So that is now the final step that you are supposed to do, and after that you continue assigning or allocating the resources that you have been given until now you fully allocate the way you have been expected, and then you now provide that step. So now using all this is like what you call the algorithm for assignment problem. These are now the steps that we need to follow so that we can solve an assignment problem. And we want to use one example so that we can be able to demonstrate exactly what we have been doing. And that example, we take it from your cost unit example number 1. So in our example number 1, you have been provided that a workshop contains 4 persons available for work on 4 jobs. Only one person can work on any one job. The following shows the cost of assigning each person to each job. The objective is to assign person to jobs such that the total assignment cost is minimum. So now, this is now the problem that we have been given. So this is the matrix. These are the persons. We have 4 persons and there are 4 jobs. So the unit element you have been provided, like now 20, 15, 19, 25, all this in the matrix is what we are referring as the unit element. So we want now to use this algorithm that I have explained to be able to solve this problem. So now, in the first step, just as I have already learned, in the first step, we need to check whether this problem is a maximization or it is a minimization. If it is a maximization, we need to look at things like if these elements that have been provided, like 2015, are what you call profit figures, because we maximize profit, we maximize revenue, we maximize customer satisfaction. That is in management. We generally maximize customer satisfaction, we maximize customers' happiness, we maximize revenue, we maximize profit. So if the unit elements are a profit, presented in the profit, that definitely tells you that this is a maximization assignment, and therefore our first step is supposed to convert it. But these are, you have been presented with cost. You know, you will minimize cost, we minimize also what we call the transporting distance from 2 different places. We also minimize wastages. So in this case, we have been provided with cost element. Definitely it tells me that this is a minimization problem. So it's already, the first condition has been satisfied. So we also need to check whether the assignment, that matrix that have been provided is balanced. So being balanced, in this case, the number of rows and the number of columns needs to be the same. Like for instance, this we have how many rows? We have 1, 2, 3, 4. There are 4 rows. And then how many columns? 1, 2, 3, 4. So this is 4 is equal to 4. This means now this is also a balanced assignment problem. If it was unbalanced, then our first duty at this first step is to balance it. It means, therefore, that our first conditions have been satisfied. It is a minimization problem, and it's also a balance problem. It means we can now move to our second step. And the second step requires that we present this matrix. This is 20, this is 15, this is 19, this is 25, this is 25, this is 18, this is 17, this is 23, and then we have 20, 22, 23, 21, 24, we have 28, we have 17, we have 24, and 24. These are now the unit elements that we have been provided to. These are the different persons here. Person number 1, 2, 3, 4, and then these are the various jobs. Job A, job B, job C, job D. So the first step that we were told is now we need to identify the row minimum. So now the first row is the unit element is 20, 25, 22, 28. Which one is going to be the least? The least is 20. So our 20 is now the least. The second row, 15, 18, 23, 17. Our list here is 15. Okay. This is 19, 17, 21, 24. The least value there is 17. Here is 25, 23, 24, 24. The least here is 23. So we need to reduce this matrix in that row by this. So when reducing this simply becomes, we take, this is the list. So this 20 minus 20, this definitely becomes 0. This becomes 5. This becomes 2. This becomes 8. And then we reduce this one also. This becomes 0. This becomes 18. We subtract this, we get 3. This we get is going to be 23 minus 15. We get to be 8. We get 8. And then here we get 2. So the second row has been reduced. We also reduce the third row. So we begin with 0, 19, this is 17, that is 2. This is 0. This is 3. Is 3 or 4? Is 6. It's not 6, 7. So we have already reduced the second, third row. So we go to the fourth row. The list is 23. So 23, when we subtract from this, we get 2 here. We get here 0. We get here 1. And then we get here also 1. So this is the reduced matrix that I've reduced minimum value. So I've only done, these are the steps that I've done. So I need now to go to the third step in the first phase. The first phase, we need to do what we call now column reduction. And checking by this, we need to identify what is now the least value in each and every column. So this is the first column, second column, third column, and fourth column. So now the first unit element is 0, 0, 2, 2. So the list here is 0. Here next is 5, 5, 0, 0. So the list there is 0. So here is 2, 8, 4, 1. The list is 1. And here is 8, 2, 7, 1. The list is 1. So this is what I need now to do my reduction using that, and then the first phase is complete. So when you see a 0, it means you leave the values the way they are. So this is 0, 0, 2, 2. Because now a 0 subtract from a number, you just get that same number. So this one also, I will leave it the way it is down in the upper matrix. So 0, 0. Now this one requires reduction because the least value here in this column is 1. So this transforms to 1, this becomes 7, this becomes 3, and then finally this one becomes 0. And then finally we do reduction with 1. So I subtract, this becomes 7, this becomes 1, this becomes 6, and then finally this becomes 0. So now I've now done this. The steps that I've taken is actually what is supposed to be done in phase 1 of solving this problem using what we call Hungarian method. So after this point, I've already reached now phase 1 is complete. Now I need to go to phase 2. And in going to phase 2, I now need to test for what we call optimality. I need to begin allocation direct. I begin to begin allocation. So I know these are jobs, and then these are various persons that are here, even if I don't present them. These are various persons. So, and these are jobs A, B, C, D. So I begin now allocating. And the rule that we learned here is in step 4 is that you identify from the first row, you begin assigning from the rows, then you try the column. So the first row here, I begin off right. I can begin it off right here, or I now need to write this matrix here for this step. This 2, 2. This is 5, 3, 0, 0. This is 1, 7, 3, 0. This is 7, 1, 6, 0. So now, you assign from unique 0. Unique 0, it means you check a row. If there's only 1 0 in that, you can assign. Like this, first row. We have 7, 1, 5, 0. So in this row, 0 is unique in this row. So I can assign this automatically. I can assign this. Okay? So in assigning this, because it is unique, it is the only 0 in that given row. That is why I'm calling it unique 0. So you are allowed to assign. So I've already assigned this job to person number 1. So now, once you have done that, it means I will never assign this part again, because assignment is one-to-one allocation. So because it is one-to-one allocation, it's like you can only assign one person to one given job. You cannot assign one person to 2 jobs at the same time, isn't it? So this is the area where there's a lot of specialization. So you do this. Once you already assign this, we will be expected to cross this given row. Remember, I've assigned at the row, but I'm supposed now, it's like I'm deleting the column because I will not do assignment again in this given column. Okay, so that is complete. So I need now to go to the second row. So when I go to the second row, I find 3, 7, 1. There is no unique 0 because this one I've already dealt with. So I skip. I will not assign at row 2 because we don't have any unique 0 in row 2. Okay, I come to row 3. Row 3, I have 0, 3, 6. So this 0 is unique in this row. So I will assign here. I will assign this because it's a unique 0. So once I've already done that, the column to where I've assigned becomes what you call, I delete it like this now. Okay, so that's what I've already done. So I move now to check what you call my 4th row. My 4th row. My 4th row, I have 0 and 0. Okay, I have 0. There are 2 zeros. Yeah, therefore these zeros are not unique. There are 2 zeros, they are not unique. Unique means it must only be 1 0. If there are 2, this is non-unique now. So it means now in the rows I'm through assigning. So I need to come to check the columns that are remaining. If there is any column which requires me that I can assign. So I come to this column. So if I come to this column, there are only 2 columns remaining, this and this. So I come to the first column is this. So is this 0 unique in the column? Is it the only 0 in that column? Yes, it is the only 0 in that column. So I will be expected to assign it. So once I've already assigned it, I'm supposed to delete the very row where I've now assigned. Now if I assign at a column, I'm supposed to delete a row. If I assign at a row, I'm supposed to delete a column. So in this case, it means this columns remains to be deleted. Now I need now to go to the 4th column. So this column now, it's now not, there is no 0 to assign. It means that this my assignment, I've managed to assign 3. I've managed to assign 3 employees, and the number of what you call, the number of jobs that were there were 4. It means 3 is not equal to 4. This is a case whereby I've failed to do what you call optimal assignment. There is one person that is still remaining unassigned to the job. So it means therefore that the last final step will be expected to take course here. So that next step is what we need to do so that I can be able to do full assignment in this case. Now because we have failed to get complete optimal assignment, therefore we need to move to the final step. And now the final step requires that according to what you call the algorithm that I had already explained previously, you need to look for the element which has not been the least element in the matrix. Now that least element at the points which have been crossed twice, so we now rewrite the matrix again. We have here 0, we have 0, we have 2, we have 2, we have 5, we have 3, 0, 0, 1, 7, 3, 0, then 7, 1, 6, 0. So in this case, in this matrix, you know that there are ones that have been crossed once. We cross these ones once. We also cross the middle one once. And then lower ones, we had the point of intersection. So what I'm referring to is the least element in an closed cell. So this element 1, 7, 7, 1, 3, 6 are not being crossed. So these are where I pick the least, and the least definitely is 1. So this one, at the point which has been crossed twice, point of intersections, I will add this one. Where they have not been crossed, I subtract this one. And the ones that have not been crossed at all, I'm supposed, that have been crossed only once, I need to leave them in the subsequent matrix the way they are. So I need to regenerate a new matrix, and I begin my assignment. So the new matrix will be, because this one has been crossed once, I will leave it the way it is, that is 0. Then this is 0, this is 2, this is crossed twice, point of intersection, it becomes 3. Then here I will have 5, I have here 3, I have here 0, here it has been crossed twice, so I add 1. So this one has not been crossed, so I subtract 1, so that is 0, so this is 6, this is 2, this is 0, I leave it the way it is, this is 6, this is 0, this is 5, and then this is 0 because it has been crossed once. So now, using this rearranged matrix, I now need to begin assigning. And the rule was, I need to assign at what you call unique 0. So the unique 0, if I look at row 1, we don't have any unique 0 because there are 2 zeros. So I skip that. Row 2, 0 and 0, there is no unique. I leave it. I skip row 2 again. Row 3, 2, 0, 2, 5. So this 0 is unique in row 3. So I need to assign it. When I assign at row, I delete what you call the corresponding column where I have signed. So this is now the matrix that I remain with. So I come to the the fourth row, I find 2 zeros. It is non-unique. So I now need to check the column. The first column you have 2 zeros. So this is not unique. This one I already deleted, so I skip it because I only have now 3 columns. So I consider this. There is also 2 zeros. So this is non-unique. This is non-unique. Now it comes to another situation whereby the rule was we need to assign at what you call unique 0. But a case whereby you try to assign at unique 0, you don't find a unique 0. You only find one like this. Then you go back and begin assigning afresh at non-0. But when you sign at non-0 and you get another one which is unique, you give unique 0 preference. A case whereby you failed to make assignment using what you call unique 0, you need now to continue and do the process again by assigning at non-unique zeros. Like now I begin matrix, the first row, this is, I begin to assign at non-unique. I will assign this. I'm now assigning this 0 at is non-unique. When I assign this, I will be expected to delete, because it is on the row, I will be expected to delete this. When I do like that, it means now I will only remain with these rows only. I've already deleted these 2. So I will remain with this. If I consider this third, this second row, you'll realize that there is 6 and 0. This 0 becomes now unique in this given row. So I will be expected now to assign this 0 at that row, and then I delete this last column. So once I do like that, I come again and then I check this. I only find at this row there is only 0. So I can consider that 0 is becoming is unique. So this I only find this 0 it's unique at this given row. So I can assign this given 0, and once I assign, I delete this one. So I consider how many assignments have I done. I've done 1, I've done 2, I've done 3, I've done 4. So and every assignment has been, it's like 1-to-1 mapping. So I now need to present these ones were various various jobs. So the jobs that I had, you present now the optimal value. The jobs were job A, B, C, D. Now job A, we assigned a person's number. So we go back to the original value. The job A, we managed to assign person number 1, and the value corresponding element is 20. Okay. Job 2, job 2, we assigned a person number 4. Person number 4. This was assigned person number 1. This has been assigned person number 4. C has been assigned person number 2, and then D has been assigned person number 3. And now the corresponding original values is what you present there, and then you add. So now job B, we assigned person number 4. So person number 4 is, what is the value? 17 unit. Yeah. Job C, we assigned person number 2, which is also 17. And then job D, we assigned person number 3. So person number 3 is 24. So if you add 20 plus 17 is 37. Plus 17 again is 54. Plus 24 is 78. So this is the unit cost of this is the optimal value of cost of making this assignment, which is 78, and this is now your final answer.